Hi, mathletes. Welcome to Thursday's lesson. Today, we're going to take a look at how you can use trigonometry to find missing side lengths in right triangles. So we're going to take a look at one case today, and then we're going to continue practicing this next week. All right, so number one, if given the angle measure, you can use a trig function to find a missing side length of a right triangle. We're going to do exactly that, and we want to round to the nearest tenth. So here's the problem pretty much, and we're just going to break it up and chunk it into the steps. So this is the problem. We were given this right triangle. We were given one of the acute angle measures and one of the side lengths, and we have an x on the side length that we are trying to find. So this is what you're going to be given, and you've got to figure out what trig ratio that you have to use. So should we use sine? Should we use cosine? Should we use tangent? So we're going to use a similar approach to what we did on Tuesday. We're going to first kind of really draw attention to that acute angle that we're working off of. So we're working off the 73-degree angle. And then you want to label the sides according to that angle. For example, what side length is the hypotenuse? What side length is opposite that angle? And what side length is adjacent to that angle? So my hypotenuse is always across from the right angle. So I know that my hypotenuse is 6. The opposite side is always that side length that's across, that doesn't touch that angle at all. So this opposite side, I don't know anything about it. And then if I put my finger on the angle that I'm working on, then I am touching that adjacent side. And this right here is the adjacent side. So you're going to be given one of the side lengths, and you're going to be asked to find one of the side lengths. And that's how you narrow down your search for what trig ratio to use. So in this problem, I know the hypotenuse and I want to know the adjacent side. So I know H, I want to know A. What trig ratio uses A and H? That uses the adjacent and the hypotenuse. If you said cosine, then you are correct. So that's how you narrow it down. You're going to be given one of the side lengths, and you're going to be asked to find one of the side lengths. And depending upon whether those sides are the opposite, adjacent, or hypotenuse, that's how you figure out what trig ratio to use. Now, when you write your equation, we know it's going to be cosine of that angle. So cosine of 73 degrees is equal to the adjacent over the hypotenuse. So when I write my equation, I'm going to have cosine of 73 degrees is equal to the adjacent side length, which I have labeled as x, over the hypotenuse, which is 6. Now notice how I put the cosine of 73 degrees over 1. You don't have to do that, but if you put anything over 1, it doesn't change the value of it. And now it just might make it easier for you to see how this equation is actually a proportion. And we studied proportions a couple of weeks ago. To solve this equation, I'm going to use my cross product property. I'm going to multiply across. So x times 1. And then I'm going to multiply across here. 6 times the cosine of 73 degrees. And so you're going to use your calculator. And if you do not have a calculator, you can use the scientific calculator on Desmos. And I'm going to pull that up right now so you know how to use that. But it's really important that if you are using your own calculator, you're going to want to make sure that you're in the right mode. So you want to make sure that you're in degrees. So if you just typed in this last problem into your calculator and you didn't get 1.8, then that means that your calculator is in the wrong mode. And you can either Google how to change it, or you can send me an email during class and I can walk you through it. but let's type this last one in. So if you don't have a calculator at home, just go to Desmos and use their scientific calculator. You can see here's your sine, cosine, tangent. You want to be in degrees. So if I click this, now it says it's in radians. I don't want to be in radians. I want it in degrees. So I'll type in 6 and then cosine of 73. And you can see right here, that's how you can use this calculator to figure out your value. So it said to round to the nearest tenth. That's why I did 1.8 on that one. Where were we? Right, this one. And there you go. So again, you're going to be given, this is the only thing that you're going to be given. You draw attention to what angle, acute angle is labeled. That's the one you want to work off of. Technically, like you could find this third angle and you could work off of that one, but it's not necessary. You're kind of making more work if you were to do that. You're not wrong if you went about it that way. You're just, kind of going the longer way about it. You want to label the hypotenuse. You want to label the opposite and the adjacent side to that angle that you're working off of. That's how you figure out whether you're using sine, cosine, or tangent. And then whatever trig ratio you are using, so for this, we had cosine of 73 degrees. Then you set it equal to that ratio setup. Cosine is always the adjacent side over the hypotenuse. The rest is algebra, solving this equation. So using your cross product property, x times 1, set it equal to 6 times the cosine of 73. Notice how I put that number in front of the trig function. All right. So for today's lesson, we're only going to look at equations where x is in the numerator. Next week, we'll take a look at, well, what happens if the unknown, if that variable is in the denominator? The algebra is just a little bit different, but it's the same process. Number 2, so this is the only thing that you're going to be given. So you're going to be given a right triangle. You're going to be given one of the angle measures, the acute angle measures. You're going to be given one of the side lengths, and then you're going to have a variable on one of the other side lengths. So label those side lengths hypotenuse, opposite, and adjacent. My hypotenuse is always that side length across from the right angle. So I know that my hypotenuse is 29. And then label your other sides. If you touch the angle, you're touching the adjacent side. That means this has to be the adjacent side, and this other side here is opposite. It's across from that angle. So I've got to narrow it down. I know the hypotenuse and I want to find the opposite. What trig ratio uses the hypotenuse and the opposite side? So what trig ratio uses O and H? If you said sine, you are correct. So when we set up our equation, we're going to be using sine. Sine of the angle measure, so sine of 19 degrees, is equal to the opposite over the hypotenuse side length. So sine of 19 degrees is equal to opposite side length, which is x, over the hypotenuse, which is 29. Here's your equation. Again, if you want to put this over 1, you can. You're going to solve it using your cross product property. So you're going to multiply across x times 1, and then you're going to multiply across here. So 29 times the sine of 19. Let's see what you get. And you should get about 9.4. And again, if you do not have your own calculator at home, you can use that Desmos scientific one. I don't love the iPhone calculator. They just make you type in the angle in a different order, and I find it more confusing for you guys. So just use the Desmos one is what I would recommend. All right, we'll do a couple. So let's take a look at some application ones. To measure the height of a tree, Louis walked 125 feet from the tree and measured a 32-degree angle from the ground to the top of the tree. Estimate the height of the tree to the nearest foot. So this is a very common application for trig, is to find the height of something. So this is the tree right here, and we're trying to find the height of it. So I'm going to label that with X. So Louis was here, and then he walked 125 feet away from the tree, and then he looked up at the top of the tree. And so the angle from his eyesight to the top of the tree is 32 degrees. Now you can still use all those same strategies of labeling the hypotenuse, labeling the opposite side, and labeling the adjacent side to the angle that you're working off of. This is the angle that we're working off of. So again, notice how I circled it to kind of draw attention to it. Label those sides. And you've got to figure out, should I use sine, cosine, or tangent? So in your right triangle, which side length did you know? You knew the adjacent side. What side length did you want to know? You want to find that opposite side. So then you think about your trig ratios. Which trig ratio, sine, cosine, or tangent, uses opposite and adjacent? And so that's why you would use tangent. It's always tangent of that angle that you're working off of. So a tangent of 32 degrees, and it's set equal to your ratio. So you set it equal to the opposite side length, which is X, over your adjacent side length, which is 125. Solve your equation. Happens to be a proportion. So if you want to put this over 1, you can. X times 1 is X. 125 times tangent of 32. And it says to round to the nearest foot, so the nearest whole number. So that tree is about 78 feet tall. All right, so those are just some practice problems. Now, all the ones that we just did, those 3 problems, they all were scenarios where X is in the numerator. Next week, we'll take a look at, well, what if when you set up your equation, the X is in the denominator? And it's just a little bit different in how you solve it with your algebra, but it's the same concept. So on Canvas in the modules, look at what's listed next. That's the practice that you should complete. If you have any questions, feel free to email me. If you are completely lost, we can set up an extra help Google Meet on Friday. So those are all things that you can kind of take advantage of if you need some extra help. I hope you have a great week. Bye, guys.